Given that y equals cos 2x over 1 plus sine 2x, show that d2y by dx squared plus 2y dy dx is equal to 0. So let's have a look at this then, this little problem here. So we're going to need to differentiate to get dy dx, aren't we, here? And also d2y by dx squared. So let's just start by differentiating this. This will be u. V, it's a quotient function, isn't it? So we use the quotient rule. But also these constituent parts, the u and the v, which is all of this, are themselves functions of a function or consist of parts which are functions of a function. So we also need to use the function of a function rule. So let's go straight into it then. So here or here, dy dx then. Use the quotient rule, v times du dx, cos differentiates to minus sine of something, multiplied by the something differentiated, which is 2, v du dx minus u times the v dx. This differentiates to 0, sine goes to cos of something, multiplied by the something differentiated, the something, this differentiates to 2, all over v squared, so it's 1 plus sine 2x squared. So let's tidy this up. So what have we got? We've got to expand this bracket. Now we've got minus 2 sine 2x outside the bracket times 1, minus 2 sine 2x then minus 2 sine 2x times sine 2x, minus 2 sine squared 2x, and this one is minus 2 cos squared 2x. So that's the top part then, all over 1 plus sine 2x squared, all squared. Okay, so that's what we've got. So what does that equal then? Let's have a look. So this is minus 2, if you look at it here common, and it's a sine squared in a bracket plus a cos squared with the minus 2 outside. So sine squared plus cos squared is 1, so it's minus 2 lots of 1 here. So I hope you can see that we can write the top as minus 2 sine 2x then, minus 2 over the 1 plus sine 2x. And if I take the minus 2 outside a bracket, which is common, write the second term first in the bracket, so that would be minus 2 here. And then this would be plus the sine 2x all over this squared, wasn't it? Sorry, forgot to write that squared. 1 plus sine 2x all squared. So one of the 1 plus sine 2x is common, top and bottom. So let's cancel that. So that equals minus 2 over 1 plus sine 2x. Okay, so that's dy dx. So we've got dy dx then, so that's the first part. Now we want d2y by dx squared, so let's just do that bit then. It's fairly easy to differentiate now. This is minus 2 over something to the power 1 here. So if you move that up top in your mind's eye, up to the top, it's 1 plus sine 2x to the minus 1, something to the minus 1. So here, let's get the second derivative then, d2y by dx squared. So it's something to the minus 1, so the minus 1 comes up to be with the minus 2, to make 2, over the 1 plus sine 2x to the 1 less power. So we would write that as squared, wouldn't we? Minus 2 in other words. But when it's underneath, it's to the power 2, multiplied by the something, because it's a function of a function, differentiated. This goes to 0, this goes to cos. 2x multiplied again by the something here, differentiated, which is 2. So we end up with 4 cos 2x then. I hope you can see that. It was just layers of functions there. About 3 layers, I think. Okay, so there's d2y by dx squared then. Now let's put them in then. So d2y by dx squared then, plus 2y, wasn't it, I think? dy dx. Let's put it in and see what we get. So the first term would be 4 cos 2x over 1 plus the sine 2x squared plus 2y. Y is the thing we started at the beginning. Let's just go and get it. Cos 2x over 1 plus sine 2x. Cos 2x over 1 plus sine 2x. There. We just double check that then. Yeah? That's y. Times dy by dx. And dy by dx we worked out as minus 2. Minus 2 over this again, so we can put a squared here. So you end up with 4 cos 2x minus 4 cos 2x. The same denominator must equal 0. So we've shown that here. So I hope you can see that. Have a look through it a few times if you need to. I'll just give a quick summary of it. First of all, we looked at this. It was a function of it was a quotient derivative, and each constituent part was itself really a function of a function, basically. So it was v du dx. The u cos of something goes to minus sine of something multiplied by the something differentiated. So v du dx minus u dv dx all over the v squared. There's the v, that object squared. More than one term, you put a bracket. Then the only tricky part here was expanding the bracket here and here for the first two terms here. And then noticing there's minus 2 common here, so you could take that outside a bracket in your mind's eye. Sine squared plus cos squared is 1, so that's just minus 2 there. So we write that on this term here. Denominator stays the same. And then we can take a minus 2 out here on this line. And inside the bracket we can write the second term first. There's a 1 to give minus 2. And then the second term is minus 2 sine 2x. So we end up with these cancelling, and we end up with 2 over just one lot of 1 plus sine 2x. Second derivative then, this is something, minus 2 lots of something to the minus 1, isn't it? So the minus 1 comes up. You think of this on top as power minus 1, so the minus power comes to be with the minus 2, to make 2, divided by the something squared, multiplied by the something differentiated. This goes to 0, this goes to cos of something itself, multiplied by that something differentiated. Tidy it up, you get this. Put them both in, and you get 0. So that's the problem.